everyone, welcome back to Tina Teach Python Projects. Today we're going to be having a lot of fun doing this program. Essentially is an aquarium, okay? We're going to be making an aquarium, and obviously we're going to have some fishes, and these fishes will be able to move on their own. And we'll also be adding, some logic, a little bit of coded behaviors for all of the fishes. Luckily, this project is not going to be as long as the previous one, which is roughly 70 minutes, if I remember correctly. I don't think we're going to have to climb Mount Everest for this one, but I am pretty excited because this is going to be fun. The name of this program is Aquarium Simulation Survival of the Fittest, and I will explain the latter part of the name in a bit as we move along with the code. For now, we're just going to import some modules, some libraries, take tkinter, naturally, because there is a graphical user interface. We need to see the little fishes moving about, and not just, text and numbers. Import math, image tk, and then the random module where it would allow us to generate the random number. Now, fish class to represent each fish in the aquarium. Def init, self, number, speed, and gravity. There will be an option to adjust directly in the program the speed and gravity of all of the fishes, so we can see some interesting behaviors resulting from these two interplay. So speed, gravity, self dot number equals to number. This will be the number assigned to the fish. Just some sort of, indicator which fish is which. Self dot speed equals to speed. Naturally, this is the speed of all of the fishes. And self dot gravity equals to gravity. The gravity applied to all of the fishes. And then we're going to initialize the positions of the fishes. We have self dot x equals to random integer or randint 750 initial x position, and then self dot y, this for the initial y position. Self dot dx equals to random choice -1 and then 1. This makes up the initial horizontal direction, and self dot dy equals to random choice. This makes up the initial vertical direction. Okay, moving on to a method to move the fish along. And I'm just going to name this function move with height, naturally, because, the whole screen is like a grid. Self.x self.x dx times self.speed, and then for y, self.dy times self.speed. This is updating the x position and updating the y position. So as they move along, the program can keep track of where all of the fishes are at. And after the movement, we're working on the collision. So if any fish collide with each other, or in this case, the images of the fish are overlapping, this will trigger the collision logic, and the fishes will try to move away from each other. So that's basically the goal of this code. Check for collision with edges and reverse direction if needed. If self.x less than or equals to 0 or self.x more than or equal to with self.dx equals to minus self.dx. If self.y is less than or equal to 0 or self.y is more than or equal to height, self.dy equals to minus self.dy. All right? And then apply the gravity with self.y plus equals to self.gravity. Okay, apply the gravity effect. Moving on to the function that checks for the collision between any given fishes. Def check collision. Fish 1, fish 2, and then fish size. Distance equals to math.square root. Bear with me here. This is a bit of a hard to look at formula. Fish1.x minus fish2.x to the power of 2 plus fish1.y minus fish2.y. If distance is less than fish size, we're going to reverse the direction whenever the two fish images overlap. So fish1.dx, fish2.dx equals to fish2.dx, fish1.dx. All right? Fish1.dy, fish2.dy, and then just like that, same thing with the dx. I'm going to move down here, Aquarium app class, to manage the graphical user interface as well as the fish movements. Class Aquarium app, function init, self root, self.root equals to root, and self.root title. This is the title of our program. Aquarium simulation, survival of the fittest. And this is the window title, okay? Self.width equals to, for me, 1,200, just a preference. This is the width of the aquarium, and this one is the height of the aquarium. The aquarium, width of the aquarium. Okay, moving on to creating a canvas widget for drawing the aquarium, and then later on I'll also write in code that will allow us to put in a background image. Self.canvas equals to tk canvas root width equals to self.width, height equals to self.height, self.canvas.pack. Just make sure that the window is correctly 1,200 and 650. Now, moving on to the background image, not background width, and creating it on the canvas. Try, and then background image equals to image tk dot photo image dot open, and I'm just going to copy and paste the path of the image that I want to display as the aquarium background. Paste it in there. I'm just gonna go with the full path, so I don't have to worry about any complications that might result from the program unable to find where the damn image is. Self.width, self.height, self dot background equals to self dot canvas create. I will show you the image of the fish and the background in my file explorer in a bit. For now, let's just work on the code, and then we'll see the folder structure, which is really simple. I put them all in the same folder. Self dot background image equals to background image. Let's go down here and have an exception as e print format error loading the background image and pass in the error. Okay, the exception. Now, initialize the fish objects or the fish images with random numbers so we can identify the fishes, since it is survival of the fittest. So we do need to know which fish makes it. Self.fishes and self.fish IDs, and then fish images, and then fish tags. These are the tags that will display the random number assigned to each fish. Now we're going to load the fish images and resize them appropriately, and make sure the image files are also in the correct directory. Try fish image equals to image tk photo image open. Now I'm going to copy and paste the full path of the image that I want to be the fish. Now resize 80 by 80 by 80. Now that's going to be the size of the image for the fishes. Exception as e print error loading fish image. Same thing with the background image, just so we know if something comes up, we know how to handle it. Fish image equals to none, so we won't have any fishes at all. It'll just be a bunch of random numbers floating around like fishes if the image fails to load. Moving on to creating any given number of fishes with random numbers. So the amount of fishes that you can have is not fixed. We can create a for loop that can generate any range of fish that we want. For now, I'm just going to go with 10 number random random integer 1 to 100. So of these 10 fishes, they can have any random number between 1 and 100, and obviously you can change this just to make sure that the bigger the range, in this case 1 to 100, it makes it less likely that any given number of fishes would have the same number assigned to them. Let's say if you have 10 fishes, but you only put the range in between 1 to 5, so 2 or 3 fishes may have the number 3, for example. Okay, so fish equals to fish number 50.5 self fishes dot append to the fish self dot fish images dot append to the fish image. So fish ID equals to self dot canvas dot create image fish dot x fish dot y and image dot fish. Okay, self dot fish IDs dot append fish ID tax ID equals to self dot canvas create tax fish dot x fish dot y tax equals to string fish dot number fill. So the color of the text is black and the font is Arial. Font size will be 10. 10. I think, yeah, 10 is good. But we'll have to see whether or not it's too big or too small when we kickstart the program. Self.fish tags append tags ID. Let's go down here and create the sliders for adjusting the speed and gravity, so we don't have to, go back and forth from our program, from our code to our program, just to change the gravity. Self.speed scale equals to tk scale root from 1 to 50. Orient tk dot horizontal label speed. So we're gonna have the label, and then we're gonna have a slider. Self.speed scale set is 5. Self.speed scale set is 5. Self.gravity scale pack, and then make sure that we can start the update loop. Self.update. No, that's it. Last but not least, we need a method to update the positions of the fishes as they move. Otherwise, they wouldn't move at all. Function update self. Now we're going to update the speed and the gravity of the fishes based on the slider value. So if we slide to a new value, that's updated and reflected in the movement of the fishes. Speed equals to self.speed scale dot get. Gravity equals to self gravity scale dot get. And then a for loop for fish in self dot fishes. Fish speed equals to speed. Fish gravity equals to gravity. And fish move to self.width and self.height. I'm just going to move the fish. And then we're going to check for the collisions between fishes, make sure that that's still working. So fish size equals to 80. Now, the difference between this fish size and the image size that we've specified earlier, 80 by 80, if you remember, is this one decides what area concerning the fish image that acts as a barrier of collision, right? So let's say you have an image of a square, and that square is like 40 by 40. If the area of collision is 40 by 40, when another object touches the edge of that square, it bounces back immediately. But if the area of collision is smaller than the square, let's say it's half smaller, then another object has to go inside, technically, like overlay, until it hit that smaller area of collision, okay? And that's exactly what we're setting up here, is the fish size. So if it's big, there will be a lot of space around the fish, and the other objects or the other fishes won't even touch the fish before they bounce away. And if it's small, they have to overlap with the fish until they hit that point of collision, or point of mass, to borrow from physics. For I in range, the length, self.fishes. Go down here for j in range, I plus 1, length self.fishes. Check collision. Earlier was for j, not for I. Self.fishes, I, self-fishes, j, and then fish size. Now that we're done checking for collision, we're going to have to update the positions of the fish images and text on the canvas. We want the text to move along with the fish. For fish, fish ID, text ID, in zip, self.fishes, self.fish-IDs, self.fish-tags, self.canvas.coords or coordinates, fish ID, fish X, fish Y, self-canvas, coordinates, tax ID. I just keep saying fish so much. It's just fish. And then scheduling the next update. Self.root.after 50. Self update. Last but not least, we have the main entry point of the program. If you remember, we have to write this at the end of every program in Python that we do. If name, main, root equals to tk.tk, this is creating the main window. App equals to Aquarium app, root, creating the Aquarium app instance, and root.main loop. So we kickstart tkinter. Okay, now we're going to run a few times to make sure that we don't have any mistakes, because sometimes I do make petty mistakes like wrong grammar or wrong keywords, or sometimes I miss a few lines of code here and there. So let's run and see what sort of debugging do we have to do. So I'm just going to go ahead and change that. Okay, so here's the problem. We have the speed scale, but we don't have the gravity scale. With gravity scale, we just have pack for some reason. We should have gravity scale set as well as the label. After adjusting that, I'm going to go down here and have this here is 5, not 0.5, sorry. 0.5 is the value for the gravity scale. Self.gravityscale, tkill.scale, root from 0, 0 to 2, resolution 0.1, orient, make sure it's horizontal, and the label is gravity. So we'll have two horizontal. Make sure it's horizontal, and the label is gravity. So now we have two horizontal sliders for both speed and gravity. Okay, self.gravity, scale set 0.5, and then self.gravity scale pack. Okay, now we're done. Let's test the program out and see, what fun antics we can get up to with this one. So this currently is my folder structure. I have Python, and in here I have Aquarium, and my main code, and then my fish, and my background, all right? Okay, so these are our little fishes. Aquarium simulation, survival of the fittest. We have the speed scale. As you can see, if you move along, it changes very quickly as well. And then this is the gravity. If there's no gravity, the speed actually, the fishes bounce around more. But if there's a lot of gravity, as you can see, they tend to go down to the bottom. Now, I'm going to explain why I call this survival of the fittest. And if you've noticed already, we now have 4 fishes. Let me just slow down so we can see the numbers: 52, 85, 43, and 83. Now, they still bounce against each other and against the side of the screen here. However, if you increase the gravity, there we go. If you increase the gravity, or max gravity and max speed, they will actually go out of bounds. Now, that's a unique behavior that we get from our code. That's why it's called survival of the fittest. What I like to do is, let's close this for a bit. I can change how much speed there are and make it 100, right? And for gravity, let's just make it 3. I don't want too much gravity in here. And I can increase the number of fishes, and I can increase the number of fishes to 30. And now here I have 30 fishes. And as you can see, when they get close to each other, they vibrate. It looks like they're fighting with each other. But some do still bounces off, right? As you can see here, very interesting. This one's having a go. There we go. Okay, and why does this happen? This has to do with the area of collision that we've assigned here. Let me go down. It should be somewhere here. I think I put it 80. Yeah, fish size 80. Now just shrink this to 20. And let's see if they still fight with each other a lot. Okay, as you can see, there's less instance of that. They just bounces off of each other. Okay, if you want them to fight more, then you can increase it from 20 to 100, let's say. Now, what I like to do, max gravity and max speed. You just let them bounce around like that. Okay, bounce around, and then stop. Now we only have a few left. And I like to do this until there's only one left. Now, I'm going to make a bet. I'm going to bet 81. 81 will be the last fish swimming. If you notice, there's actually a pattern to the way the fish bounces around, even though it's just, it's quite random. Okay, now let's decrease that. All right, I already lost. 81 already died. Let's see which fish survived. So we have 2 left, 2 left, 2 left. 66. Okay, 66, the only surviving fish. Quite a fun game if you're bored and you have nothing to do and you just want to practice Python. There are so many metrics that you can change. Let me make this 150 to make it look way more interesting, right? They can look like that. It's quite funny. So have fun, everyone. Thank you for tuning in. And don't forget to like, subscribe, and comment. Stay tuned for the next video and have fun coding. See you next time.